guys, we really gotta start thinking about this.
Yeah. Hey guys, y'all know what I learned in calculus today?
There's this thing called a power differentiand for calculus, in which if f of x is equal to x to the n, then f prime of x would be equal to x to the n minus 1 times n. And there's also something called the power for integration, which is basically the opposite, in which the integral of x to the n dx would be equal to x to the power of n plus 1 over n plus 1, and don't forget plus c.
Isn't that so cool, guys? Hello? Guys? So do we have a deal?
If this is coming from an angle of 34 degrees, traveling in a rate modeled by 24x plus 3.6 feet per second to my head, then it leaves only 0.0833 seconds for me to duck under it, and if I get hit, I'll miss my calc final and fail.
That's why I don't mess with a calc student. Oh my god, my mask is up.
We can estimate areas under curves using Riemann sums. Here are two graphs with x squared with the points 2, 4, 6, and 8 plotted. So let's first take a look at the graph on the left. We can estimate the area under the curve by getting the area of each of these squares, and to do that would be based on height. So the base would be the distance between each of the points modeled by delta x. In this case, delta x will be equal to 2. Now, since we're evaluating using left endpoints with 4 subintervals, we'll be evaluating using the first 4 points given in the graph. So that would be delta x multiplied by f of 0 plus f of 2 plus f of 4 plus f of 6. Since each of these represent the heights of the rectangles. And that gives us 2 times 0 plus 4 plus 16 plus 36, which is equal to 112. Now, see, look at the graph on the right. Similarly, delta x would still be 2, since the distance is still 2 between each of the rectangles. Now we're using right endpoints to evaluate, meaning we take the last 4 given points of the subintervals, right? So here it would be delta x times f of 2 plus f of 4 plus f of 6 plus f of 8. And that would be 2 times 4 plus 16 plus 36 plus 64, which gives us 240. Riemann sums can be over or under estimations, depending on whether you use left or right endpoints, as well as the behavior of the graph. And here you're saying, Dylan, you don't actually care and you only had 9 reasons. Oh yeah? Shut up! Ask anyone, they'll tell you my favorite shape is rectangles used to over or underestimate areas under curves.
I'm not feeding my dog tonight.
Oh my god, what is he listening to?
Hey Dad, I got my calc test back. Hello? Hello? Wait, they got his egg!
Oh, you got it?
Yeah.
Don't feel like picking up my phone, so leave a message.
Oh my. What am I supposed to do with this?
Calculus, dumbass.
Oh. Okay. A limit represents the value that a function approaches or gets arbitrarily close to as the input approaches a specific value. By examining the behavior of a function near a particular point, limits enable us to determine continuity, identify asymptotes, and evaluate indeterminate forms. They provide the basis for defining derivatives and integrals. Derivatives measure the rate of change of a function at any given point. They provide valuable information about how a function behaves locally, capturing its instantaneous rate of change or slope of a tangent line. The derivative of a function can be interpreted as the function's rate of change or its velocity at a specific point, often modeled by f prime of x or dy over dx. It allows us to find critical points, determine concavity, identify relative extrema, and analyze optimization problems. Integrals are used to calculate the accumulation or total of a quantity over an interval. They reverse the process of differentiation by finding the antiderivative of a function. Integrals have two main interpretations. As definite integrals, they represent the area between a function and the x-axis over a specific interval. As indefinite integrals, they yield a family of functions whose derivative match the original function, known as antiderivatives. The integrals are essentials for finding areas, calculating volumes, computing averages, solving differential equations, and modeling real-world phenomena. So the integral of 1 over x dx is ln absolute value x.
Hsieh.
I just got fired from work, and your mother and I are getting divorced.
Huh? Wait.
Now let's see how we can use calculus to solve this. If the angle of elevation of the sun is decreasing by 1 over 4 radians per hour, then df theta over dft is negative 1 over 4 radians per hour. And we're going to evaluate at theta is equal to power 4. Let's estimate the height of his head to be around 4.6 feet, and x will be the shadow of a man who just lost everything in his life. To find x, we can use 4.6 over x is equal to tangent theta, so x is equal to 4.6 over tangent theta. If we derive with respect to t to find the rate at which the shadow is changing, then dx over dt is equal to negative 4.6 times secant squared theta over tangent squared theta times d of theta over d of t. At theta is equal to pi over 4, and using d of theta is over d of t is equal to negative 1 over 4, then dx over dt is equal to negative 4.6 times 2 times negative 1 over 4, which equal to 2.3 feet per hour. Now, how does that solve this problem? It doesn't. Welcome to calculus.
Hsieh.
You slept with my boyfriend.
Yeah, and then that's why I told her.
Carry on.